Hey everybody, welcome back. In today's video, we're going to talk about multiplying polynomials. In my previous videos, we have classified polynomials. We've put them in the correct order called standard form. Yesterday we talked about adding and subtracting polynomials. Today we're going to look at multiplying them. This is the last thing my kids actually did in class before our break. So this should still be a little bit familiar to them. One thing that I want everyone to know again, with multiplying polynomials, there are multiple ways to get these answers. I'm going to show you 4 different ways to get a correct answer to a multiplying polynomial question today. And like I tell my kids in class all the time, you don't have to learn all 4 and be an expert at all 4. Find the one that works the best for you, the one that your brain seems to be the most compatible with, and go with that method every single time. Now I'm going to show you all 4 just so everyone's exposed to them. But like I said, you can pick the one you like and you can go with it. All right. A lot of times, not all the time, but a lot of times, especially in Algebra 1 or in like a regular math class where you're just first learning this, maybe in pre-algebra, it'll usually be a binomial, which technically this is all one term since it's in parentheses, but you know how I mean, there's 2 things in this parentheses and there's 2 parts in the second parentheses. Usually it's going to be like that, a binomial and another binomial. And so we're going to start off with binomials, and then at the end of the video we'll progress to something that's a little bit more complicated. But when it's a binomial and another binomial, one of the methods is the distributive property. Now, if you're in Algebra 1, you're probably familiar with the distributive property already. Usually whenever you learn it on a question that's maybe similar to this, right? This would be like a 7th grade math question, or maybe even a 6th grade math question, possibly 8th grade, depending on your school and where you live. And the way I teach this to my kids way back in the beginning, whenever I review this, is I just say, hey, your whole life you learn PEMDAS, please excuse my dear Aunt Sally, parentheses have to come first. Well, what happens when you can't answer the parentheses, right? There is no answer to w plus 6. You can't come up with an answer for that. How am I supposed to do the parentheses first when I can't answer the parentheses, right? And so for some kids, that's a big stumbling block for them. But usually when that happens, you're going to see there's a number right in front of the parentheses. And remember, when there's no symbol in there, it's multiplying. And you're going to take the number that's outside the parentheses and you're going to distribute it. You're going to hand it out. You're going to pass it out. You're going to give it away like Oprah giving away free cars on her talk show. You're going to pass it out to everybody. And everything's going to get multiplied by the number that's outside of the parentheses. So like for this example, I would do w times 5, and I would do 6 times 5, right? And so 5 times w is 5w, and then 5 times 6, it's a positive 6 because we have this plus sign right here. 5 times 6 is 30, right? That is the distributive property. You take the number that's outside of the parentheses and you distribute it, you pass it out, you multiply it by every single part of the parentheses, right? If I had 3 or 4 things all being added in that parentheses, all of the things that are in the parentheses would be multiplied by 5. All right, so that's the quick introduction to the distributive property. And so the method you can use to multiply polynomials is to distribute, right? And I like to draw the arrows. You don't necessarily have to draw the arrows. Some students, once they get familiar with this, don't actually draw them. They can just do it quickly in their head, but I like to draw them. I would do x times x, and most students, by the time they get to 8th grade or Algebra 1, can multiply x times x in their head and say x squared. Oh, that is right in the glare. I apologize about that. And then I'll draw another arrow. You have to do x times this 2, and the 2 has a minus in front of it. And so that's really x times negative 2, because it has the subtracting in front of it. So that's negative 2x. And I'll move this down out of the glare here in a second. And then what I'll do, usually in my class, because I have the luxury of having different colors, then I'll take the 5, this positive 5. It also is going to get multiplied by both things in this parentheses, right? Positive 5 times x is plus 5x. And then I'll also do this positive 5 times the 2, but it has a minus in front of it, so it's almost like positive 5 times negative 2. Positive 5 times negative 2 is negative 10. Let me go ahead and move that down, get the glare out of the way. Oh, maybe. Well, the glare might just be there. I apologize about that. There we go. And so you should have, when you have a binomial and another binomial, you should have 4 terms in your, I don't want to say answer because it's not a final answer yet. You should have 4 terms here, and usually it's the 2 in the middle that are combinable, right? These are like terms, aren't they? They're both x to the first power. They are both first degree. And so we can follow yesterday's advice as far as combining like terms. We can add those together. Negative 2, because the symbol in front of it is part of it. Negative 2x plus 5x Negative 2 plus 5 is 3x. And then the rest of this stuff can just get dropped right down, right? X squared, there's no other x squareds to combine it with. I don't have a symbol there. Don't get hung up on that. Just ask yourself, was this positive 3 or negative 3? And if you look up there, it was positive 3, so put a plus. And then right here, the minus 10, we're just going to drop it down. Whoops, my 10 doesn't look very neat, but that is a negative 10 at the end of the answer, or a minus 10. Okay, that is the method called the distributive property, right? The first part of the parentheses gets multiplied by the entire second parentheses, and then the second term in that first parentheses gets multiplied by everything. Okay? It helps when you have different colors like I do. So if you have highlighters at your house or different colors, crayons, or not crayons, colored pencils, you could use those as well. A second method, which is maybe a little bit more time consuming, but can still give you the answer, is to draw a table. It kind of looks like a Foursquare court if you ever played Foursquare growing up in elementary school. And the way you can do this, you take one of the parentheses, x and plus 5. You can put it over here, an x and a plus 5, or you can put it up here. It doesn't really matter. Just for the sake of this video, I'm just going to put x, and I'm going to go ahead and put positive 5 right there. And then for the other parentheses, you can put that along the top. Once again, doesn't really matter. X and minus 2. And then it's just almost like a old school multiplying chart, right? Did you ever have to learn your multiplying facts with one of those multiplying charts, you know, where you'd have to, okay, follow the, it'd have like 1, 2, 3, 4, 5, 6, like this, and then it'd have the same thing going down here, and it would have all the answers, right? And you'd have to like match up. If you wanted to know 2 times 1, you'd have to find the little square that would say, okay, 2 and 1, and then if you wanted to know 4 times 5, you'd say, okay, there's the 4, there's the 5, and there would be a little box right here with 20. It's kind of the same idea with this. In this box, we're going to do x times x. X times x is x squared. In this box down here, you're going to do x times the 5, right? X times 5 is kind of the intersection right here. And so 5 times x is 5x's. Sloppy x, but I apologize. Over here, you're going to have negative 2 and the x. And so negative 2 times x. And then in this bottom right-hand corner, you have the negative 2 kind of meeting up with the positive 5. And you're multiplying, don't forget, this is multiplying. 5 times negative 2 is negative 10. And so you get your 4 boxes filled in. And once you get the 4 boxes filled in, you can find the 2 that are combinable. You should have 2 answers that are like terms, like it's right here, the plus 5x and the minus 2x. Those are combinable. So we'll combine those together when we prepare to do our final answer. When I do my final answer, though, this one should be first because it's to the second degree. It's the second power. So that should be first. And my answer, if I want it in standard form, these two are both to the first degree. They're both x to the first power, so I can combine those. 5 minus 2 is 3, positive 3, so I put a plus. And then this is to the degree 0, and so that's going to go at the end. And you can see it's the same answer I had up above. That is just another method. Now, my personal students in my classes this year haven't really preferred this method, not because it's that hard, but probably just because it takes more time to draw the boxes and get it all set up. So if you have time and you like art and you like drawing and that makes sense to you, go ahead and draw that out every single time. It will take a little more space, but it is another method to get the same answer. Okay, there's 2 more methods to do these questions. Let me transfer my boards. Another one that's super popular, you'll see in algebra books all across the world, not just in the United States, is to do the FOIL method. Now, a quick disclaimer here. The FOIL method only works with binomials, right? Binomials. When you have 2 things in the first parentheses being added or subtracted, and you have 2 parts to the second parentheses being added or subtracted. FOIL will only work whenever you have 2 terms here and 2 terms here. It will not work on any other type of question. FOIL is an acronym for kind of a shortcut, helping you remember what to multiply. The F stands for first, and that means you multiply the first term in each parentheses. Right here, F and F, right? 3x times x. And sometimes I have my kids, especially when they're first learning it, write it out. 3x times x, and then they can put the answer, 3x squared. Now, eventually my students will get good enough where they don't need to write it out every time, but especially at the beginning, I always have them write it out. The O stands for the outer or the outside terms. Some people say outside, some people say outer. Outside meaning like the bookends, right? Where would you put, if you're going to take a press and like squish this together, where you'd be pushing, right? So we have 3x on the outside, on the left side. On the right-hand side, it's not just 8. Don't get fooled. It's the minus sign in front of it as a part of it. It's negative 8. And so it's 3x times negative 8. And 3x times negative 8 is negative 24x. Okay? If O stands for outer, you can probably guess what I stands for. I stands for the inner terms, right? The two on the insides, kind of like the insides, the guts of it here, deep in the middle. And so on the insides of mine, I have this positive 5, and here an x. So 5 times x, that's just 5 x's. Not too difficult on that. And then the only one we have left is the letter L. If F stood for first, you can probably guess what L stands for. L stands for last. And it's not the last part of the question, it's the last part of each parentheses. So like right here, positive 5, right here, negative 8. And so usually, unless they get really tricky with the question, usually the letter L is just two regular numbers, right? See, my L here is positive 5. My letter L in the second parentheses, the last part of the second parentheses, is this negative 8. I know it's technically a subtracting sign, but whenever you drop it down here, you act like it's a negative. 5 times negative 8 is negative 40, right? And so if you take a look, the way I labeled it, see how I have two things for this, 2 letters for the 5. Each part gets used twice, right? That should work every single time. Now you get to this point, you're like, all right, I'm ready for my final answer. The letter F, 90% of the time, is going to be your highest degree, unless they write the question really weird. That's to the second power, so that's going to go first. And then it's usually the 2 in the middle that are combinable, right? The OI, the O and the I, for you guys who used to watch poker back in the day. There was that Australian guy who won the World Series of Poker, Joe Hasham, I think, and his fans would always go, oi, 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 for Australia. And so anyway, negative 24x and 5x, we can combine those. Let's see, negative 24, this is a positive 5. Negative 24 plus 5 is negative 19x, I believe. And then at the very end, the letter L is usually just your degree 0, so that goes last. Okay, that is the FOIL method. F stands for the first term in each parentheses. O stands for the 2 on the outside. The I stands for the 2 terms on the inside. And then the L represents the last term in each parentheses. You should always have that O and the I, the OI, that is combinable. Those are the only 2 pieces right here that you end up adding or subtracting whenever you get to the end. Okay? Feel free to rewind the video and watch that again, because that one can be a little complicated for people, but some people use that as their preferred method. And then one more, and I'll be honest with everybody, I mean, I've been teaching algebra for, I don't know, this is my 15th year. I didn't even realize that this was a method until this year. I actually have kids in my class who like this the best. The vertical format. When I say vertical format, do you all remember like in elementary school when you first learned to multiply? And you multiplied a question like this, right? And we all learned to do this, and then you just drop down to the second row, and your teacher would either have you put a 0 or an X right there, and then you would go 4 times 3, carry the 1, and then you know how it would go from here, right? You would add all that up, you get your answer. That's what I refer to as the vertical format, or learning the actual algorithm on how to multiply. You can do the same type of thing on a question like this. You're like, excuse me? How is that possible? This doesn't even look like the same type of a question. How could that even work? Well, just watch. You could take the first one, x minus 7. You could take the second term. I'm going to make my multiplying problem right there. X plus 5. I'm going to go ahead and make it a different color just to make it stand out. And you can multiply this exactly like you learned in elementary school. It's going to feel a little bit weird, but it is possible, right? Could I do positive 5 times negative 7? Yeah. Negative 35. Now don't carry it. That's the only thing that's a little bit different, right? I had a student who tried this in class, and they put the 5, and then they tried to carry the 3 up here. No. Don't worry about that. That's the only thing that's different from this to what you learned in elementary school. You don't have to carry anything if your answer is bigger than 10. Just kind of write it down, right? And then when you do 5 times x, that's 5x. Just like in elementary school, when you start your second row, you start with a 0, and then the second row, x times negative 7 is negative 7x, and then right here, x times x is x squared. And you can see what we're going to get here, just like in elementary. You add them up. The 0, you can put a plus in front of it because really adding 0 doesn't do anything. And look, it's already lined up perfectly in the correct format. Negative 35 plus 0 is negative 35. Here, 5x minus 7x, 5 minus 7 is negative 2x. And then x squared doesn't have anything to combine with, so you just drop it down, right? And so I actually have 8th graders who use this strategy. It's familiar to them because it's the same way they learned in elementary school and in 5th grade, 6th grade, 7th grade. The only thing that's a little bit weird, like right here, when you multiplied at the very beginning, don't carry any numbers, right? Don't like put the 5 and then carry the 3. That's going to mess it up. Just put the whole number down. And other than that, it's the exact same thing. This vertical format I'd never done before. In fact, I didn't even know it was possible until I looked this year and saw a different way to do it. And I actually have kids who are doing it this way. Okay, one last thing. What if it's not binomials, right? You're thinking, okay, buddy, your questions are looking nice and easy, but they're not always going to be 2 binomials. What happens when they start putting more than 2 terms in the parentheses? Let me move my table. Oh, that's not the right way. Get it out of the glare a little bit. There we go. What happens when you don't have just 2 terms in each parentheses, right? So the FOIL method is going to be worthless on a question like this, where you have 3 parts in this parentheses and you have 3 parts in this parentheses. You cannot do FOIL. It's not going to help you. You could still do distributing. You could still do the table if you wanted. You could even still do the vertical format. Just my personal opinion, and you don't have to do this, my personal opinion is that distributing is the best. But that's just my personal preference, right? I would do x times 3x. I would do x times 2y. Now, this is kind of weird because you've got an x times a y, but that's all right. X times 2y is just going to be 2xy. See, I put those in alphabetical order. I would do x times negative 7. That's negative 7x. All right, so I distributed the x to everything. And now I'm going to distribute this 6 to everything, and I'm going to put the arrows up above just so it's easier to see. Positive 6 times 3x, and I'm going to run out of space over here, but I'll make it work. Positive 6 times 2y, 6 times 2y, that's 12y. I'm just going to go down underneath. And then positive 6 times negative 7 is negative 42. And so you can see how earlier I had 4 terms in my final answer. Or not final answer, but when I got done with my distributing, now look, I've got 1, 2, 3, 4, 5, 6 different terms. And some of them are combinable, but not all of them are, right? The only 2 I see here that I can combine together are these 2, because they have regular x's on them. But everything else, I've got a y, I've got an xy, and I have an x squared. So as far as my order, the second degree, x squared is the highest degree. I'm going to make that go first. This, I'm going to go put a box around it so I don't forget it. This is also to the second degree, and I'm going to put that second, 2xy. And then my 2 plain old x's should come before the y because I'm going in alphabetical order. These 2 right here, negative 7 plus 18, that should be 11 x's. And then my first degree here, my y, doesn't have any other y's to combine with. And then minus 42 is degree 0. That is very complicated. I actually made that question harder than I wanted to. You probably won't get many questions like that, but that is a method that you can use whenever you have more than one, or you have more than 2 terms in one of the parentheses. My last question here is probably a little bit more simple. Let me do the distributive property one more time. You can do 3y times y squared. That's going to be 3y to the third, right? 3y times 4y. 3 times 4 is 12. And then y times y is y squared. If I do 3y times negative 1, that's just going to make it negative 3y. And so I'm halfway done. I've distributed the 3 to everything. And now I need to distribute the 5. And it's not just the 5, it has a minus sign in front of it. So this is like negative 5 that I'm multiplying times everything right here. Negative 5 times y squared is negative 5y squared. Negative 5 times 4y's. Okay, negative 5 times 4, that's negative 20. And just put the y right there. And then here at the end, negative 5 times negative 1, because it has a minus in front of it. Negative times negative is positive, and then 5 times 1 is 5. Okay, so I have 6 terms again in my expression. I'm not done though, because I can combine some of these together. What is combinable in here? Well, I'll get to that in a minute. This should go first. Third degree. That's the first part of my answer. I have 2 things that are squared, right? Y squared and y squared. Notice I'm taking that sign that's in front of it. I'm not just putting the 5 and the 12. I have positive 12 and negative 5, or minus 5. 12 minus 5 is 7, positive 7, so I'm going to put a plus. Same thing with the regular y's, right? Right here, negative 3y. Right here, negative 20y. Negative 3 and negative 20 make negative 23. And then the very last one, degree 0, is the plus 5. So this one is probably a better example than my one right above it. That is the way it normally goes whenever you have multiple, multiple pieces in that last parentheses or in the first parentheses where you can't just do FOIL. Okay, I'm at 20 minutes. I need to stop this again. So one more time, in case you're wanting to practice this, if you're a student in one of my classes, I have already posted on the Big Ideas Math in my algebra class website. I've already posted an assignment or practice questions with 20 different questions practicing this. There are unlimited, you have unlimited chances to do it. So if you don't do so well, you can just restart it. There should be videos that you can watch if you get stuck and hints you can look at. But if you don't have that option because you're not a student in my class, these 2 websites are both free. If I can get it out of the glare. These 2 websites are both free. Let me turn the light off. No, there's still a glare. Where you can go to either one of these places. There we go. And you can access free questions that you can print off or just do on pencil and paper if you don't have a printer at your house. So they should have a section titled Multiplying Polynomials, and feel free to use it because they have the questions and the answers. All right, one more time. Thank you so much for watching this video, and I'll be back tomorrow, or Monday, I'll be back Monday with a new one. Have a good day.